To the casual observer, the moon is a silent companion, a silver lantern that has hung in the night sky for as long as humans have walked the earth. We see it as a symbol of romance, a guide for ancient navigators, and the first milestone in our journey toward the stars. But the moon is far more than just a beautiful nightlight. It is a fundamental component of the Earth's operating system. If the moon were to suddenly vanish, or if it had never existed, in the first place the Earth would not just be darker. It would be an unrecognizable, hostile world where complex life might never have stood a chance. To understand what the moon does for us, we have to look back at our violent origins and realize that we live on a double-planet system where our destiny is inextricably linked to our lunar neighbor. The story of the moon begins with a cataclysmic event roughly 4.5 billion years ago, known as the giant impact hypothesis. In the early chaotic days of the solar system, a Mars-sized protoplanet named Theia slammed into the young, molten Earth. This collision was so energetic that it nearly obliterated both worlds, sending a massive cloud of vaporized rock into orbit. Over time, this debris coalesced into the moon. This wasn't just a random accident. It was the defining moment that gave Earth its unique characteristics. The impact tilted our planet's axis and accelerated its spin, while the resulting moon became a gravitational anchor that has held our world steady ever since. Without that collision, and without that anchor, the Earth would be a chaotic, wobbling ball of rock with extreme weather and an unpredictable climate. The most immediate and visible change in a moonless world would be the behavior of our oceans. We often think of the tides as a minor inconvenience for sailors or a fun part of a beach vacation, but they are the heartbeat of our planet's hydrosphere. The moon's gravity pulls on the Earth's oceans, creating bulges of water that move across the globe as the planet rotates. While the sun also exerts a gravitational pull on our water, it is much further away, and its tidal effect is only about 40% as strong as the moon's. Without the moon, our tides would be weak, sluggish, and driven solely by the sun. This would be a death sentence for coastal ecosystems. The intertidal zone, the area between high and low tide, is one of the most biologically productive environments on Earth. It is a nursery for thousands of species, providing a unique habitat where life is forced to adapt to both water and air. For the early history of life, the loss of strong tides would have been a catastrophic hurdle. Many biologists believe that the rhythmic ebb and flow of the tides provided the bridge for life to move from the sea to the land. Tide pools are natural laboratories of evolution, where marine organisms are trapped in shallow water and forced to survive in changing temperatures and salinity levels. This constant environmental pressure encouraged the development of lungs and sturdy fins that eventually became legs. In a moonless world, the transition of life to land might have been delayed by hundreds of millions of years, or it might have happened in a completely different, much slower way. We might not have been a planet of mammals and forests, but a world of deep-sea dwellers where the continents remain barren and silent. Beyond the tides, the moon plays a critical role in regulating the very length of our day. When the Earth was young, it spun much faster than it does today. Shortly after the impact with Theia, a day on Earth lasted only about 6 hours. The Earth was a dizzying, whirling world of fire and storm. It was the moon that acted as a gravitational brake. Through a process called tidal friction, the moon's gravity creates a slight drag on the Earth's rotation. Over billions of years, this has slowly drained the Earth's rotational energy, stretching the day from 6 hours to the 24 hours we enjoy today. Without the moon to slow us down, we would still be living on a 6-hour day world. Imagine the chaos of a 6-hour day. The Earth would have to rotate 4 times as fast as it does now. This rapid rotation would generate terrifying atmospheric conditions. On a fast-spinning planet, the Coriolis effect, the force that deflects winds, would be much more powerful. This would create atmospheric banding, similar to what we see on Jupiter or Saturn. Instead of our current weather patterns, we would face constant planet-wide gales with wind speeds exceeding 100 or 200 miles per hour. Hurricanes would be more frequent and much more violent, and the simple act of a plant growing toward the sun would be a struggle against relentless, high-speed winds. Complex land-based plants might never have evolved beyond low-lying mosses and shrubs, unable to withstand the atmospheric fury of a fast-spinning Earth. Perhaps the most terrifying consequence of losing the moon involves the stability of our planet's tilt. Earth currently sits at an angle of about 23.5 degrees relative to its orbit around the sun. This tilt is what gives us our seasons. Because of the moon's massive presence, this tilt stays remarkably stable, varying by only a tiny fraction over tens of thousands of years. This stability has allowed Earth to maintain a relatively predictable climate, with ice ages and warm periods occurring in slow, manageable cycles. Without the moon, the Earth would lose its gyroscope. Its tilt would wobble wildly, influenced by the gravitational tugging of Jupiter and the other planets. We can see the evidence of this in our neighbor Mars. Because Mars only has 2 tiny asteroid-sized moons, Phobos and Deimos, it lacks a gravitational stabilizer. As a result, the tilt of Mars has wobbled by as much as 60 degrees over its history. If the Earth were to experience such a wobble, the consequences would be apocalyptic. At times, the Earth might tilt so far that one pole points directly at the sun for months at a time, while the other is plunged into a frozen, permanent night. The oceans would migrate toward the poles. The ice caps would melt and reform in different locations, and the climate would shift so rapidly that most species would have no time to adapt. A moonless Earth would be a world of climatic chaos, where the seasons are not a gentle cycle but a series of planetary-scale disasters. The biological impact of the moon also extends to the behavior of animals themselves. Many species rely on the moon for navigation, hunting, and mating. Nocturnal predators, such as owls and lions, have evolved eyes that are finely tuned to the faint silver light of a full moon. Marine species, like the mass-spawning corals of the Great Barrier Reef, synchronize their reproduction with the phases of the moon, releasing millions of eggs and sperm in a single, coordinated event triggered by lunar cues. In a world without a moon, these biological rhythms would be shattered. Migratory birds that use the moon as a nocturnal landmark would become lost. The predator-prey balance of the night would be tilted in favor of those who can hunt in total darkness, fundamentally changing the evolutionary path of thousands of species. From a human perspective, the absence of the moon would have rewritten our entire cultural and scientific history. Since the dawn of humanity, the moon has been our first clock and our first calendar. The word month is derived from the word moon, and almost every ancient civilization used the lunar cycle to track time, agriculture, and religious festivals. Without the moon, we would have had no natural way to divide the year into smaller, manageable units. Our early mathematical and astronomical skills were sharpened by trying to predict eclipses and track the moon's phases. Without this training ground in the sky, our understanding of geometry, physics, and the nature of the universe would have developed much more slowly. The moon also served as the primary catalyst for the space age. In the mid-20th century, the moon was the perfect, reachable target. It was close enough that we could see its craters with the naked eye, yet far enough to challenge our greatest engineering minds. The race to the moon drove a technological explosion in computing, materials science, and rocketry that defines the modern world. If there were no moon, we would have no stepping stone to the rest of the solar system. Mars is hundreds of times further away than the moon. Without the intermediate goal of the Apollo missions, it is unlikely that humanity would have invested the trillions of dollars and the massive effort required to break the bonds of Earth's gravity. We would be a planet-bound species, looking up at a dark, empty sky with no obvious destination to strive for. Furthermore, the moon acts as a protective shield for the Earth. Though it is smaller, its surface is covered in millions of craters, many of which were caused by asteroids and comets that might otherwise have headed for Earth. The moon's gravity helps to deflect, or soak up some of the cosmic debris that litters the solar system. While it doesn't catch everything, it has certainly served as a silent guardian for billions of years. Without the moon, the Earth might have experienced a higher frequency of impacts, potentially interrupting the long periods of stability required for complex life to thrive and evolve. In the search for life on other planets, astronomers are now realizing just how rare and important a large moon might be. Most planets in the galaxy likely do not have a moon as large as ours relative to its parent planet. This suggests that the Goldilocks conditions we have on Earth's stable tilt, 24-hour days, moderate tides, might be incredibly rare. When we look at the hundreds of exoplanets discovered in distant star systems, we are beginning to ask not just if they are in the habitable zone for water, but if they have a moon-like stabilizer. Without such a neighbor, even a planet with the right temperature might be too chaotic for life to ever move beyond the microbial stage. Ultimately, the moon is the quiet partner in the story of life. We often focus on the sun as the source of energy and the Earth as the source of matter, but the moon is the provider of rhythm and stability. It is the reason our days are long enough for us to rest, the reason our seasons are predictable enough for us to farm, and the reason our planet doesn't wobble like a dying top. It is the light that guided our ancestors out of the darkness and the beacon that calls us to explore the stars. To ask, what if there was no moon, is to realize that we are incredibly lucky. We live in a rare moment of cosmic history, on a world that was perfectly shaped by a violent collision to become a sanctuary for life. As we look toward the future, the moon will become even more important. It is the site of our future lunar bases, our mining operations for rare minerals, and our launching pad for missions to the outer planets. It is a piece of Earth that was cast off billions of years ago, waiting for us to return. If we ever do encounter an alien civilization, they might find it strange that we spent so much time taking our moon for granted. They might see it for what it truly is, the most important piece of real estate in the solar system, second only to the Earth itself. The moon isn't just a rock in the sky. It is the reason we are here to look at it. In conclusion, the presence of the moon is a testament to the fact that beauty and utility can exist in the same space. It is beautiful to look at, but its utility is what allows us to exist to appreciate that beauty. From the tides that nurture our life to the stability that protects our climate, the moon is the unsung hero of the Earth. If it were to vanish tomorrow, the Earth would begin a slow, inevitable descent into chaos, a world of howling winds, wobbling poles, and a shattered biological clock. We should look at the moon with a new sense of gratitude, realizing that the silver light reflected on our windows at night is more than just a glow. It is the force that keeps our world together.